Hey, physical science, this is the last day of the week. It's Thursday, April 30th. Can you turn to page 554? Make sure you got this thing out. And I left this up here on the board as kind of a review of what we did last time. Now, if you remember, we were talking about combining lithium. The metal lithium is element number 3 on the periodic table, and the element fluorine. Fluorine is element number 9 on the periodic table. Lithium has got 3 protons and 3 electrons. Fluorine has 9 protons and therefore 9 electrons. Now, what I'd like to do is just to review, this is a metal and that's a non-metal. The metals are losers. Losers of what? Losers of electrons. Which electrons? The electrons in the outermost energy level. The non-metals are gainers. Gainers of what? Gainers of electrons. Which electrons? The electrons on the outermost energy level. It's like as though this electron, there's an empty bed right there in that hotel. There's 1, 2, 3, 4, 5, 6, 7 electrons. They want a stable octet of 8 electrons in the outermost energy level. And so it pulls one in from empty space or from a nearby atom. And the nearby atom wants to get rid of that one because if it can, it would have 2 electrons on the outermost energy level, which is now the first energy level. And so if it had 2 electrons, it would be feeling like helium, which has 2 electrons on the outermost energy level. Because 3 minus 1 is 2, and the element number 2 is helium. And on this one, it has 9 electrons, and if it gains 1, it has 10. And element number 10 is neon. These noble gases are stable. The reason they're stable is because they have a full outer energy level. Energy level 1 can have 2 electrons. When this one ionizes, that means gain or lose an electron, or 2 or 3 electrons. When it ionizes, it no longer has a second energy level, and so the outermost energy level is full. When this one gains an electron, its outermost energy level is full, which is the second energy level. This one turns into a charged atom called an ion of, well, what is 3 minus 2 plus 1? This one is, what is 9, positive 9 plus negative 10, because it got the 10th electron. It's negative 1. Now, the gainers are becoming more negative, and the losers are becoming more positive. How can you lose stuff and have it become more positive? The answer to that is you're losing negative stuff. It's kind of like losing bills. If you lose bills, you get richer, kind of. And so losing negative stuff means you get more positive. Metals are losers. They form positive charged particles called ions. And non-metals, these over here, are gainers. They gain electrons and become negative ions. And now the positive ion and the negative ion electrically hook together. And so it forms this compound. And so what's that holding that compound together? We call it ionic bonding, because these are ions that are holding together. Now, you don't see the brackets on this formula, but the brackets are only used when we're trying to show that it's an ion, it's charged. You could, I suppose, put a plus right up here and a negative right up there, and you'd see that the positives and the negatives hold it together. But that wouldn't be proper format. Okay, look on page 554 at the top. That's right up here at all of these models of these atoms. I had you draw 2 models, and up there, they've got a whole bunch. And so what we're going to look at is lithium. Do you see the lithium atom? 2 electrons on the first energy level and 1 on the second. That's what I drew here. Do you see fluorine? You got the same model. It's missing an 8th electron. It really wants to have that 8th electron to become stable, to become like a noble gas on the outside. And so it'll gain that from a metal. So the blue ones over here are the metals. The yellow ones over here are the non-metals. The blue ones are the losers of electrons, and the yellow ones are the gainers of electrons. Look at sodium, Na. It has 3 energy levels, but it has 1 electron on the 3rd energy level. So the first group has 1 dangling electron, that's what I call it, on the outermost energy level. The second group has 2 dangling electrons on its outermost energy level, which for beryllium is the 2nd energy level, and for magnesium, its outer energy level is the 3rd energy level. Now, for aluminum, it has 4 energy levels, but it has, it says 13. Aluminum is group 13. Yeah, subtract 10 from that and make it a 3. Subtract 10 from 14 and make it a 4, and then make this a 5, and make this a 6, and make that a 7, and make that an 8. And what that does is it tells you how many electrons are in the outermost energy level. So if this group 17 has 7 electrons in the outer energy level, all of them, fluorine, chlorine, bromine, iodine, and astatine, they all need 1 more electron. Well, what about group 16, which I call group 6? Group 16 needs 2 electrons because what's 6 plus 2? It's a stable octet. Take the element oxygen. How many total electrons does oxygen have? 8. How many are in the first energy level? 2. Leaving me how many for the second energy level? 6. Now, if you look at the period number over here, it will tell you that the element lithium has 1 dangling electron, and that's the group number, and then the period number is 2. It's on the second energy level. Right below that, sodium has 1 dangling electron on the 3rd energy level. Magnesium right next door. Magnesium has 2 electrons. See up the top there, 2. Where? On the 3rd energy level. Go over here to aluminum. Aluminum has 3 electrons. Where? On the, come back over here, 3rd energy level. Gallium. Gallium has 3 electrons on the 4th energy level. Can you tell me about the first energy level? It has 2, it's full. And second energy level is full. 3rd energy level is full. The 4th energy level has 3 electrons on it. And so the one over here, oxygen and sulfur and selenium and tellurium, they all have 6 on their outermost energy level. And they're trying to show you that with those pictures. Now, there are electron dot diagrams, and you can see that the dots correspond to the number of electrons on the outermost energy level. So a dot diagram for anything in group 1 would have 1 dot next to it. Like here, rubidium. Rubidium would have 1 dot next to it. Over here, silicon. Silicon would have 4 dots next to it. The number of electrons on the outermost energy level is the number of dots you put next to the symbol. And the reason is because when you're talking about combinations of elements, atoms hooking together, you're talking about the outermost energy level electrons only. Any of the inner energy level electrons are buried too deep to be involved in chemical reactions. Chemical reactions only occur on the outermost energy levels. So that's the dots. That's why we look at those and consider those. Well, that pretty much covers 554 and 555. Stability is achieved when the outer energy level is the same as that of a noble gas. And then on 556, if you look over here, there are some times when atoms will share. So we have atoms that lose and atoms that gain. And the third situation is when atoms share electrons. And water is an example of that. Water is H2O. That's not very good. I put that away. Brand spanking new black ones here. Let's see if this works better. Water is H2O. The one we were considering a moment ago, I think, was lithium fluoride. Now, lithium is a metal. Fluorine is a nonmetal. Hydrogen is a nonmetal, and oxygen is a nonmetal. This bonding up here is called ionic bonding because they form ions. And these are losers, and these are gainers of electrons. And these down here are sharing electrons. Sharing electrons, losing electrons, gaining electrons. Losers are the metals, gainers are the nonmetals, but when you have two nonmetals together in a formula, carbon dioxide is another one, that kind of thing, nonmetal, 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 you're going to be sharing electrons. It's like this. What group is oxygen in? It's 16, which I'm calling 6. Just cut 10 of it away. Okay, group 6. That means it has 6 dots around it. So let's put them out there. 1, 2, 3, 4, 5, 6. Doesn't oxygen want to have a stable octet on its outermost energy level? It does, so that it can have 2 more. 8 plus 2 is 10. It'll look like neon on the outside, on the electrons. So along comes a hydrogen. A hydrogen has 1 electron. And the oxygen says, I have 6, I need 8 on my outermost energy level. It says, you have 1, can I borrow your electron? And hydrogen says, yeah, you can borrow my electron if I can borrow 1 of yours. Because I need 2 to become stable. And then another hydrogen comes along and says the same thing. I mean, oxygen says, I have 6. Well, I get to have hydrogens too. Because hydrogen just threw his toys in here. And I threw my toy over there. And we both played with those two. We both played with those 2 toys. We're sharing. So hydrogen gets the benefit of having 2 electrons, and I get the benefit of having 7. But that's not enough. I need 8. So this other hydrogen, the same deal. He throws his toy in there, and he throws his toy, that's called electron, in there. They're sharing electrons. The hydrogen gets the benefit of feeling like it has 2, 1 of his own and 1 of oxygen's. And oxygen gets the benefit, let me make this a little bit bigger, of having 8. Yeah. So it has 6 of its own, whoops, excuse me, dot. 6 of its own, and then 1 from this hydrogen and 1 from that hydrogen. So what is the formula called? H2O1. Isn't that interesting? All right, so that's called sharing electrons to achieve a more stable arrangement of electrons to form water. What's a chemical bond on 556? It's a force that holds atoms together in a compound. That force is because electrons are shared, gained, or lost. Look on page 558. You know what? I think we've talked long enough. Let's just quit right there and we'll start section 2 on Monday. See ya.